Good afternoon, everyone. Thank you for joining us today to our Energy Efficiency for Small and Medium-Sized Business webinar. My name is Lorena, and I'll be hosting today's webinar. I'm going to be monitoring chat and conducting a poll at the end of the session, and you'll see that to the right of your screen. If at any point you have any questions or run into any issues, please feel free to chat them to me. Today, we'll be covering a few tips and things to look out for in small and medium-sized businesses, and hope that it'll help you apply at your facility to save energy and money. We also want to thank our sponsors, Energy Trust of Oregon and Northwest Energy Efficiency Alliance, which you'll see their logos on the bottom of the screen. Based on our customer feedback, they appreciate that we continue to work with them and are aligned to eliminate any confusion regarding the messages that we deliver to customers on energy efficiency and renewables. Before I introduce the presenter, I wanted to show you some of the tools that we'll be using today. Again, on the right side of your screen is a chat window, but on the top left corner of your screen under the Quick Start window where I'm drawing this red line here are some of the tools. There's an arrow, a T for text, a highlighter, markers. Those are some of the tools you'll be able to use today during this session, and the instructor will let you know when to use those to make it interactive for you. We want to have you participate, and hopefully that way the concepts will stick with you and you'll be able to do some examples when you get back to your facility. And if you have any questions, again, submit them through me, and we do have some time dedicated at the end to address them. So Garrett Harris is the Commercial Energy Specialist at Portland General Electric. He has over 10 years of experience in educating and advising customers on energy efficiency technologies. So he goes in and talks to people about their walkthroughs and what they can do to save energy and money. He also works really close with the Energy Trust of Oregon to provide incentives to our customers, well, to inform us about what we can take advantage of, and then also any business tax credits that are available. He also has a degree from Lane Community College in Energy Management and a Business Management degree from Linfield College. So Garrett, we'll go ahead and have you get started here.
Good afternoon. Before we get started today, I just want to quickly go over an agenda so you can kind of expect and understand what we're going to be talking about. So first off, we're going to start with calculating energy usage. So just basically some simple calculations where you can calculate how different devices or lighting systems, how much energy is used based on the type of equipment. Business energy use, where different businesses, commercial buildings, where energy is used, what kind of equipment, lighting, heating, and cooling, and so on. So we'll go over lighting opportunities, a lot of lighting opportunities in commercial buildings. We'll address specific technologies. Same thing with HVAC, heating and cooling systems. We'll also go over some low and no cost ways to save energy. So these are going to be things that you can do, after we get done with the webinar today, maybe some suggestions that you can implement. We'll talk about Energy Trust, who the Energy Trust is, and the incentives the Energy Trust offers. And getting started, our next steps, if you identify some good opportunities, well, how do you go about making improvements, get money, and implement projects? So a couple concepts that we want to address here, energy and power. So power is the rate at which work is done. With electrical energy, we're talking about watts. Energy is power over time, or kilowatt hour, and that's the billing unit or unit of measurement for using electricity. So in kind of a comparison to, let's say, a car, power might be horsepower, and energy used would be gallons, but in utilities, it's kilowatt hours for electricity. So calculating energy consumption. Here's a basic formula. We're going to determine the watts of the light bulb or whatever the piece of equipment is, multiply by hours, divide by 1,000, and we get kilowatt hours. So in the 100-watt incandescent light bulb example, if we had this 100-watt bulb operating for 2,920 hours, which is 8 hours a day for 365 days a year, divide by 1,000, we'd get 292 kilowatt hours, which would be the annual consumption. And here's another way of looking at just a little more graphic detail. 100 watt incandescent bulb multiplied by hours time, divide by 1,000, and we get the 292 kilowatt hours. So calculating the cost, PGE billing unit for energy is kilowatt hour. Schedule 32 business customers pay about 8 cents a kilowatt hour, and this represents a lot of small to mid-sized businesses. So we'll look at the 100 watt light bulb example again. 100 watts times hours, 2920 divided by 1,000. Okay, we got our kilowatt hours. Now to move to cost, we need to multiply kilowatt hours by the rate, which is again is about 8 cents. So basically, it's going to cost about $23.50 to operate this incandescent light bulb for a year, 8 hours a day. And just another graphic depicting the same thing: 100 watt light bulb hours divided by 1,000, and we're just multiplying the cost in there, 8 cents times 292 kilowatt hours, $23.50 is the cost. So we'll do a practice problem here. Review the formula again. Watts times hours divided by 1,000 equals kilowatt hours. Kilowatt hour cost, 8 cents a kilowatt hour. And so in this practice problem, we'll calculate the consumption for a 20 watt LED lamp, which has approximately the equivalent light output of a 100 watt incandescent. So how much does it cost to operate this 20 watt light bulb LED for 2,920 hours? So we've given you a hint down here, basically the formula where you can plug in some numbers to get the kilowatt hour usage, and then multiply that kilowatt hour usage that you found times the rate. So what I'll do is give everyone a few minutes just to plug in some numbers here, and remember the toolbar on the top left hand side of your screen. You can indicate with a number of the tools what the correct answer is. So I'll just give everyone a few moments to do this practice problem, and then we can reveal the answer. Well, it looks like we've got several participants that got the correct answer. It is $4.67 cost to operate that 20 watt LED. So kind of putting it all together here, 100 watt incandescent, 2,920 hours is going to be 292 kilowatt hours. 20 watt LED, same hours, 58 kilowatt hours. And cost for the incandescent for a year, $23.50, and cost to operate the LED, $4.67. So what does that mean? Replacing the 100 watt incandescent with a 20 watt LED saves about $18.82 per year. So, pretty good investment, and it's a pretty significant savings just switching out one lamp. So I know everyone's at lunch today and probably wasn't in the mood for a math class, so there won't be any more calculations. We'll kind of look at high-level opportunities and things you can look at your business. But looking at doing the calculations, I think will be helpful, a tool you can use in identifying energy consumption at your business. So we are done with doing any math problems. What we have here is business energy use, kind of national average, top 6 uses of commercial electricity in the United States. Key thing I wanted to point out here was the significance of lighting. We can see that it's by far the biggest user, but if you add space cooling and space heating together, still pretty significant and a major energy consumer in commercial buildings, but primarily lighting. For most businesses. So we'll look at different building types, different business types. So in an office building, what we're looking at here is total energy use. So this isn't just electricity. This is electricity for cooling and lighting, but also factoring in costs for heating with natural gas or oil or any other fuel source. Lighting is, even looking at the big picture with all fuels, lighting is still pretty significant, 23%. Space heating's pretty big as well, 27%, and water heating 23%. But moving over and looking at just electricity alone, you can see how significant lighting is, about 46%. Space cooling and ventilation, HVAC, also pretty significant there, but definitely lighting the biggest. Now moving towards retail, you can see the percentage of lighting energy, or overall energy use in lighting is much greater than the previous slide in office building. You see very high light levels in retail environments. Product is being sold, highlighted, a lot of halogen lighting, track lighting, stuff like that. High light levels, just different than an office, for example. So 55%, pretty big. And just looking at electricity, moving up to about 59%, almost 60%. Again, space cooling and ventilation, pretty significant. And all the other and office equipment here in retail and office spaces is still fairly significant, a lot of plug loads as well. Warehouse space is a little bit different, but still lighting is pretty significant. Typically, you see a lot of pretty significant space heating, 38%. The warehouse space is typically heated with gas unit heaters, and it's going to be a pretty significant portion of the overall energy use, but lighting's big, and usually not much cooling or other kind of miscellaneous loads in warehouses. And then when you move to the electric side, only lighting's 56%, not much cooling in a warehouse space, just kind of other miscellaneous equipment, maybe forklifts and stuff like that, electric. So we'll talk about some of the lighting opportunities and why you would want to upgrade your lighting systems. First and foremost, saving energy and reducing operating expenses or utility costs. A big driver to looking at those systems. All of these upgrades are very cost effective. Reducing maintenance costs. So another monetary benefit, but not utility, energy saving benefit is increased lamp life. So upgrading to newer generation fluorescent, linear fluorescent lights or fluorescent tubes or to LEDs. Often the lamp life is much greater than some of the older technologies, so less time and money spent on maintaining the lighting systems moving forward. Also improving lighting quality in workspace and retail environments. So in workspace, like an office space, for example, there's often, getting the right light level and lighting quality studies have shown that workers are much more productive when they're happy and have good, high quality and appropriate light levels. And of course, in retail environments, you're trying to enhance the product you're selling. So anytime you can improve the light quality, there should be a direct correlation and a good impact on selling product. It's often the largest area of consumption, as we've seen in the previous slides, and often one of the most cost-effective improvements that can be made in a commercial building. One of the most common types of commercial lighting that's seen in commercial space is linear fluorescent. These are often, 4-foot fixtures seen in office, some other more small industrial or auto repair shops, warehouses sometimes see 8-foot fluorescent fixtures. So one of the older technology is T12, the T12 fluorescent. The T12s are 1.5 inches in diameter. They're operated off of a magnetic ballast typically. The newer generation of fluorescent lighting is T8, so they're 1 inch in diameter, a little narrower. They operate off of a much more efficient electronic ballast. So there's a lot of benefits to upgrading from T12 to T8. Typically, you don't have to replace the entire fixture. You can retrofit the fixtures, just a lamp ballast replacement, often lamp holders too. So improving the light quality. One of the metrics of light quality is color rendering index, and this is basically the ability of artificial light to accurately display colors. So the color rendering index of a T8 is going to be much better than T12 typically. You're going to see much longer lamp life with a T8 lighting system over a T12. Some of the newer high performance T8 lamps are lasting in the 24 to up to 50,000 hours. Standard T12 is going to be in the 20,000 hour range. So a lot less frequent replacement of the fluorescent tubes. In working with our customers, I found a typical payback is in the 2 to 4 year range. A lot of it depends obviously on cost of installation and difficulty and hours of operation, but this is kind of a typical range that I see. There's also a T12 phase out, so a lot of the basically the T12 magnetic ballasts have been already been phased out. Most of the T12 fluorescent tubes that are commonly used in commercial environment, they have been phased out. They'll still be on the market, and in a sense, there is a little bit of a loophole that some high CRI T12 lamps will be available, but likely at an increased cost and really no energy savings. But the lamps will likely be more difficult to get a hold of moving forward. So we'll look at a typical office retrofit. So let's say this is a small office. It has 24 130 watt 3-lamp T12 fixtures, and the lighting upgrade or retrofit would be retrofitting these 24 fixtures with a 55 watt system, 2-lamp T8 lamp and ballast combination. And we would plug in some hours of operation, 10 hours a day, 5 days a week, plus 4 hours a day on Saturdays. So the annual energy savings, you're getting close to almost 5,000 kilowatt hours a year. A dollar savings, about $413. The energy trust incentive that comes into play would be about $720. So a simple payback after incentives, 2.3 years, and return on investment, 43%. So very cost effective, good investment, good project. High bay lighting is often seen in warehouse space, industrial, small industrial, auto repair shops, even some big box stores will have this type of lighting. So the two types of HID, high intensity discharge high bay lights would be high pressure sodium or metal halide. So on the left-hand side there, you've got just two examples of either metal halide or high pressure sodium. High pressure sodium has the yellow light, and metal halide has a more of a white light. So you can replace these with a fluorescent fixture, and that's represented in the photograph to the right. So basically, these are fixtures with 4-foot tubes in them, kind of enclosed fixtures. They can have as few as a couple lamps to 6 or more lamps. Kind of depends on the wattage of the existing metal halide. So one of the things you're going to do when you replace the metal halide or high pressure sodium with fluorescent is you're going to improve the light quality. So the color rendering index that I mentioned earlier in the fluorescent example, it's going to be much improved going from high pressure sodium metal halide to fluorescent as well. You can utilize occupancy sensors. So anyone familiar with these metal halides or high pressure sodiums knows that they're going to take about 5 minutes to get to the full brightness. And occupancy sensors don't work real well with this type of fixture. With the fluorescent fixtures, what you can do is you can have individually mounted occupancy sensors on each individual fixture. So, for example, if you were to walk down this aisle in this warehouse and the lights were off, the lights would turn on until you stopped, basically. So as you walked under each one, they would be lit. And typical payback, in the 2 to 5 year range. Again, it's going to depend on hours of operation and so on, but generally a pretty cost-effective upgrade.
And Garrett, what's the comparison of the light level before and the after when you change them out? Does that change?
It all depends on what you're looking for. So you want to design the lighting so it meets the need of the space. If you have a light level that you are comfortable with, it would just be a matter of choosing a fluorescent high bay fixture that's going to have the equivalent light output. So it's just making the right choice for the light level that's needed in the space. One thing to note, there's lumen depreciation with the metal halide or high pressure sodium. So you lose, the light level drops off pretty rapidly from the initial output with these type of fixtures. That's not really the case. It's pretty minimal with fluorescent. So another factor to consider as well. So what we have here is a high bay replacement example. So it could be in a warehouse or maybe small manufacturing, even retail. Existing lighting, 20 461 watt metal halide high bay fixtures. So it's really using like a 400 watt lamp, factoring the ballast in. That's the actual wattage of the fixture. Upgrading and replacing those fixtures with 20 222 watt fluorescent high bay fixtures with occupancy sensors, if it's appropriate for the space, and a lot of times it is. So this is assuming annual hours of operation, 10 hours a day, 6 days a week. The annual energy savings is expected to be almost 18,000 kilowatt hours. Annual dollar savings, about $1,500. Energy trust incentive, about $2,400, resulting in a simple payback after incentives of 2.1 years, or return on an investment of 48%. So looks like a really good project. So LED lighting, we see LED lighting a lot of the time in retail, also in restaurants, bars, and so on. So a lot of track lighting, and sometimes the recessed can lighting, either using halogen or incandescent lamps. So LED is kind of an emerging technology. It's becoming a lot more affordable and very cost effective in a lot of instances. Some of the benefits with from converting to LED lighting from halogen or incandescent, much longer lamp life. So 25 to 50,000 hours. Kind of put things in perspective, there's about 8,700 hours in a year. So LED lamps are very long lasting. So you might compare, if you were comparing it to, let's say, a halogen lamp, one LED lamp is equivalent in terms of its life. It would outlast 12 to 25 halogen lamps. And you could almost make the case from a maintenance perspective that this is a good upgrade, not even factoring in energy and energy savings, which is huge as well. But another factor to consider, just the maintenance and replacement cost of all those extra halogen lamps. A lot of dimmable options, see that a lot, especially in food service, bars, stuff like that. So it's nice to have that flexibility. Typical payback, 1 to 3 years. I've seen it be really cost effective, particularly in cases where you have really long hours of operation, which is the case a lot of the time for restaurant, food service, and retail businesses. So we have a LED example here, either maybe restaurant, retail. Existing lighting would be 40 MR16 35-watt halogen track lamps. The lighting upgrade, just replacing lamp for lamp with 40 MR16 5-watt LED lamps. We're assuming 12 hours a day, 7 days a week. Annual energy savings over 5,100 kilowatt hours. And annual dollar savings, $428. Energy trust incentive that comes into play on this one, about $600. So a simple payback, it's really short here, just 1.4 years, or return on investment, 71%. Exit signs are another opportunity. So if you have incandescent or fluorescent exit signs, you can either retrofit or replace the fixture with LED. LED is going to last 50+ thousand hours of fluorescent, and it's only 3 watts. And incandescent's going to last probably a couple thousand hours and be at 40 watts. A fluorescent's a little bit better, but still about 18 watts and 10,000 hour life. So much longer lamp life, a significantly lower energy consumption. Payback is generally 1 to 2 year range. Also note on exit signs, maybe they don't add up in terms of a high percentage of the lighting load, but they're on all the time for safety reasons. So a good but smaller project. As we talked earlier about retrofitting T12s with newer generation high performance T8s. There's also potentially an opportunity to replace older generation T8 lamps and ballasts with reduced wattage, high performance T8 lamps and ballast. So you'll see a jump in the color rendering index with this particular upgrade. Longer lamp life, standard T8 still in the 20,000 hour range, and as I mentioned earlier, 24 to 50,000 hours with reduced wattage or high performance T8s. So this is an option when you're faced with failing ballasts. Let's say the ballasts are 10 or 15 years old. One choice is to spot replace the ballast and lamps as they go out, knowing that this is going to be kind of an ongoing issue. There aren't any incentives to do anything like this. You're probably going to end up with the same light level, not much energy savings. But if you looked at it as a project, you can actually get some money back to retrofit, an entire lighting system with newer generation T8s and possibly reduce wattage and so on. It might be reducing the number of lamps or changing the ballast factor, of the ballast you're using. So it can make sense in a lot of instances with the failing ballasts, or if the space is overlit. So sometimes I'll see a space like an office space, for example, that is way overlit. So kind of recommended light levels for in offices maybe 30 to 50 foot candles. I've seen 80, 90, 100 foot candles. Just way more light than's really needed. So you can see a pretty significant reduction just in addressing the appropriate light levels. So 25% or more energy savings possible with this type of upgrade. Occupancy sensors. This can be a good opportunity if the space calls for it. So this would be, you'd consider occupancy sensors in areas with intermittent use. So this might be individual offices or bathrooms, perhaps storage areas or a stock room in a retail business. So the concept here is pretty straightforward. When there's no occupancy, no movement, lights turn off, you're reducing the operating time of the lights. Payback is typically in the 2 to 4 year range for this improvement. So we have a few different types of occupancy sensors here. On the far left is a fixture-mounted occupancy sensor. So when we were looking at the high bay fixtures, you might see something like this on like a high bay fixture. Moving to the right in the middle, the round sensor. This is something that's ceiling mounted and maybe needed for some installations. And then on the far right, this is just like a switch replacement wall-mounted occupancy sensor. So this is really common to see these types of sensors in, like a meeting room or individual offices. So I'll give you a minute here just to kind of think about some of the different upgrades that we've talked about or opportunities. And if you'd use the toolbar on the top left again to maybe select some of the opportunities that your business or your space might have. So I've just listed most of the technologies that we've covered. So using the tool, if you could just take a moment and maybe select a few. All right, so it looks like we've got a wide variety of lighting systems out there. These are generally the most common, and it sounds like there's maybe a number of opportunities amongst the participants today for improvements. So we'll move on to HVAC. So rooftop units, they're probably one of the more common types of HVAC systems found in commercial buildings. What we have in the picture here is a gas unit with air conditioning and furnace all in one unit with supply and return ducts on the back side of it that you can't get a real good picture of, but it's a sheet metal behind it. So these are very common. Sometimes they're heat pump. I'd say the most common would be gas with air conditioning. So these units, typically have, somewhat limited life. You might expect maybe 20 years out of them. When you're faced with major repairs, it's a good idea to look at the high efficiency options. Don't maybe just look at the cheaper option that's, standard or federal minimum. Look at the high efficiency options and, again, incentives for this type of upgrade. Generally, it doesn't make sense or pencil out to replace these for efficiency's sake alone. But at the time of replacement, it can be and should be something that's looked at. So, potential cooling savings, looking at a code unit versus a high efficiency unit, looking at 5 to 15%. So worth looking at. So split system heat pumps and air conditioners. A lot of smaller buildings, commercial buildings, will have more residential size or a type of a split cooling system or heat pump. This happens to be an outdoor unit for a heat pump. So much like the rooftop package units, it can make sense to go with high efficiency options at end of equipment life. Potential cooling savings, 5 to 15%. Potential heat pump savings, code versus high efficiency, again, 5 to 15%. So there's also a lot of combustion furnaces out there in commercial buildings, maybe residential size, but burning either natural gas or oil. So replacing these furnaces with high efficiency condensing models at end of equipment life, it's a good opportunity when you hit that point. Maybe the heat exchanger fails and the unit's 20 years old. You can go with standard efficiency, or you can go with 90+% efficient like gas, for example, even up to 95%. So a pretty big jump, maybe 5 to 15% savings over the older unit or code. So we have a picture here of several units. I believe we've got a couple gas furnaces and a couple oil furnaces. The units on the end are taking the combustion air from outside with the PVC pipe, have secondary heat exchangers. So those are the high efficiency models I was referring to. Combustion unit heaters are another common commercial heating system. This unit happens to be in a retail space, small retail space, and you sometimes see them in retail or rarely in office. Probably most common in more industrial or warehouse space, but there's a lot of these units out there. So replacing these unit heaters with high efficiency models at end of equipment life with either a more efficient unit or even radiant heaters. So an example where a radiant heater may make sense would be like, let's say, a warehouse. So with the unit heater, you're heating all the space. And maybe you just have 1 or 2 people working there, and they're working in the same area most of the day. You can have a radiant heater, which is basically just heating an object or the people under it, as opposed to heating the entire space. You can see some significant savings there. But it doesn't work in all spaces, but when it can, a lot of potential savings. So potential heating savings, roughly 10 to 25% unit to unit. But if you have the potential to go to radiant, the savings can be a lot more significant, maybe 10 to 60%. Package terminal air conditioners, or PTAC units. These are often seen in hotels and motels and sometimes in really any type of commercial building, even an office space. So the typical package terminal air conditioner does have electric heat in the form of strip heat. So if you replace these with a heat pump, you're going to get a big efficiency gain on the heating side and potential to get a benefit on the cooling side as well. So cooling savings 10 to 25%, and potential heating savings up to 15% or 50%, excuse me. So probably not as common, but seen in commercial buildings occasionally would be zonal electric heat. So zonal electric heat, these are going to be baseboard heaters or wall heaters. Opportunity here is to replace zonal electric systems with ductless heat pumps. So ductless heat pumps are becoming a lot more common in the U.S. They were developed in Japan a number of years ago, like over 50 years ago. They're extremely efficient, kind of a proven technology in a big jump in efficiency. So basically the concept here is you have an outdoor unit. So during the heating season, it's extracting heat from the outdoor ambient air and moving it to the inside to the indoor unit. So as the name implies, a ductless heat pump, there are no ducts. It's kind of like a very small furnace mounted to this indoor unit. So It's kind of difficult to get perspective here, but on the indoor unit, it's about 3 feet wide and about maybe a foot tall. So you can have, this is more of a residential size system, but can be a good fit for a lot of smaller businesses. You can get a single unit, or you can get units that have up to 4 indoor units per individual outdoor unit. So good for spaces where you need to add some cooling and spot heating and want to get a jump in efficiency. So up to 50%, kind of a conservative estimate, but good savings there with the ductless heat pump. We'll cover some low and no-cost lighting opportunities. So something that I see quite a bit when I'm out working with customers, lights that are on in the middle of the day. So a lot of exterior lighting is controlled by photocells. So it's basically just a sensor. When it senses that there isn't very much light, the lights turn on. And if the photocells aren't cleaned regularly, it can be the middle of the day. There's so much dirt and dust that accumulates on those. The lights stay on all the time. So just a matter of cleaning those sensors off or photocells off on a regular basis. It really limits operating time to dusk till dawn with outdoor lighting. And we're at a time of the year right now where you can really benefit from daylighting. So just things as simple as opening curtains and blinds, being able to cut the lights. Even in Oregon, spring through fall is a good time to really maximize daylighting. And compact fluorescents, a lot of us are using these at home. And it's a good low-cost replacement lamp for incandescents and residential type fixtures that are sometimes seen in commercial buildings. And just as simple as turning the lights off in occupied rooms and getting people that you work with in the habit of doing so, just eliminating, reducing the hours of operation. So we'll move on to low and no cost on heating, cooling, and water heating. A relatively low cost improvement would be installing programmable thermostats and making sure that they're set on schedule. So there's still a lot of manual thermostats, and sometimes they don't get set back nights and weekends. And if you have a programmable thermostat, you're ensuring that a schedule's kind of adhered to, and you're kind of maximizing savings with a pretty low-level investment. Ensuring that existing programmable thermostats match occupancy schedule, daylight savings, or as the schedule changes due to hours worked and so on. And sometimes you'll find that with an older system or older thermostat, maybe the instruction manual is lost and no one knows how to figure it out. Your HVAC contractor could be a good resource in explaining how the system works. Or I've even found that online you can find older manuals for thermostats and making sure that your existing thermostat is working. You're able to program it, it's set where it should be. So at PGE, we suggest some optimized thermostat set points. Occupied, we suggest 70 degrees in heating and cooling 74 degrees, and unoccupied cooling to 80 and heating to 60 degrees. So these are kind of general guidelines. In the heating season, the more you can lower the temperature, setting a set point, more energy savings you're going to see, and the opposite in the cooling season. So kind of what you can tolerate and what your customers, employees can find tolerable to work in or in NBM. Schedule employees to work the same shift to reduce occupied hours. So I mean, just simply everybody has the same 8-hour or 10-hour shift, whatever it is. There's not like a big overlap that might result in an extra 4 hours of operation of the heating and cooling system. This could also apply to lighting as well. Schedule the janitorial staff to work during occupied hours. So maybe they're in a couple hours during the night. Well, maybe they could work a couple hours in the morning, or let's say 4 to 6 when the building's still occupied during the day, and keeping the lighting, the heating, cooling systems stuck on a schedule and limiting the hours of operation. Performing regular maintenance on HVAC equipment. So this really applies to almost any type of HVAC equipment, but making sure that filters are changed regularly, you're getting good airflow for ducted systems. The refrigerant charge is, it's properly charged, no leaks, refrigerant leaks, anything like that. So it's an efficiency issue, but it's also it plays into equipment longevity, kind of maintaining your investment. And reducing water heater temperature to 120 degrees. Most, offices, retail, really all they're going to have is, a bathroom sink or a few bathroom sinks and maybe a small lunchroom, kitchen sink. You don't really have much of a water heating load there, and there's really no need to have a temperature set much more than 120 degrees. So plug loads, we did notice that that they can be significant when looking at overall usage, from the pie charts that we looked at earlier. So what you can do is you can take an inventory of plug loads, just get a sense of what devices are using energy, how much. So the Energy Trust has made available a metering device. It's basically a very small plug-in meter that's available at public libraries. I believe the brand is Kilowatt is what they used to have, and I think they're still using. So what you can do is you can plug it in the wall and then plug devices into it, and you can get the instantaneous, well, how many watts is it consuming? But it also calculates over time, how many kilowatt hours the device is using. So you get a sense of what your bigger equipment is and what you want to focus on and what you can focus on reducing energy consumption. So the wattage is listed on most devices. So we plugged in some numbers with a lighting problem earlier, but you could do the same thing for really any equipment, assuming that it's going to have a constant draw. So if it's something that varies a lot, it's kind of difficult to do without actually metering it. But if it's consistent, it's 100 watts or 200 watts, and it is that way while it's operating, you can calculate the cost pretty easily. So performing an after-hours night audit. So after everyone's left, take a look at what's on commonly used devices and personal devices. Is everything that's on, does it need to be on? Copy machines or any personal stuff that people have on their desks. Maybe it's water feature, a small waterfall or something that I've seen folks have in their offices. Is that needed, and is it needed at night? Probably not. So just unplugging unused electronic equipment after you've identified what's needed and what's not needed. And of course, limiting the use of high-consuming personal appliances. And turning off all personal appliances, off at night. So a lot of equipment, such as personal computers, they have energy settings that you're just maximizing the savings by addressing the settings on their sleep mode and stuff like that. If the devices have that, just investigate. Hey, are you maximizing or utilizing those features? Replacing personal electric resistance heaters with radiant heaters. So here at PGE, we've basically banned personal electric resistance heaters. So these are the little box heaters that people will put under their desks. Maybe it's 1,000 watts or 1,500 watts. And it's just, they're used because, everybody has different levels of temperatures that they're comfortable at. So these can be replaced with radiant heaters, and we're using these, and people are happy with them at PGE. So the radiant heater is just placed under the desk, and it's only heating basically your body if you're sitting in front of it, and not the entire space. And going, maybe it's 1,000 watts to a couple hundred watts. So a lot of savings there, but also making sure that everybody's comfortable as well. The Energy Trust of Oregon. Energy Trust is a nonprofit organization, and basically their mission is to help Oregonians save energy. And what they offer is different programs where you can get incentives for different upgrades. It was created by a Senate bill, and it's funded through the public purpose charge. So you as PGE, a business customer, pay, it's basically a small percentage of your bill on an ongoing basis to the Energy Trust. You pay PGE, PGE passes it on, and the Energy Trust in turn has these programs that you can take advantage of. So I always suggest that, as a customer, you're paying into these programs. They're good programs. Take advantage of them. Maybe you identified some opportunities today that you can look into and get some pretty good incentives and save some energy at the same time. So PGE has a close partnership with the Energy Trust. We're available as a resource to our commercial customers. We can help you participate in Energy Trust programs. So that might mean, identifying opportunities, explaining how the program works, prioritizing what your opportunities might be, and so on. We can kind of show you the ropes and help you move through the process. So this is just kind of a sample of the areas or technologies where Energy Trust incentives come into play. So lighting retrofit or replacement and controls, like occupancy sensors, for example. There's incentives for all kinds of lighting projects. HVAC upgrades. So for most of the small and mid-sized business, they have some standard incentives where you get X dollars per unit depending on size to replace rooftop package units or heat pumps or a number of different technologies. There's industry-specific equipment for grocers. So this might be refrigeration, night covers, compressor upgrades, things of that nature that are all kind of standard incentives as well. Refrigerator replacement or recycling. Maybe you have an old refrigerator from the 70s that's costs a couple $100 a year to run, and you can maybe replace it with an Energy Star unit that's costs you, let's say, $40 a year to operate. Energy Trust has incentives for both replacement and recycling. PC power management. So this is software for customers with a fairly large number of PCs where you can get some incentives to install software to address kind of energy management of them. Insulation, so in commercial buildings that don't have any ceiling or roof insulation or wall insulation, there's some pretty healthy incentives to insulate those areas. Lodging and food service equipment, things like efficient exhaust hoods in kitchens, gas fryers, refrigeration equipment, a number of specific incentives for equipment that these customers buy on an ongoing basis. And custom projects, so this typically applies to larger buildings that maybe have chillers instead of rooftop package units or large boilers, where there's some engineering analysis involved and some custom incentives that typically don't apply to a lot of the small and mid-size, which I suspect most of you who are here today have probably smaller buildings, not high-rise buildings, for example. Multifamily properties with 5+ units. Energy Trust considers these multifamily properties really commercial building, and they offer some good incentives. Some examples of incentives would be increasing insulation levels, replacing windows, common area lighting, appliances like refrigerators, dishwashers. So a pretty wide variety for the multifamily property owners. And a new construction or a major remodel. So when you're building a new building, there's an opportunity to not just meet code, but to exceed code. And Energy Trust will pay incentives to do that. They offer design assistance and kind of different packages depending on what you want to do with your building. Maybe you want to go LEED certified, and there's some help to do that. So just one thing to note with Energy Trust, a lot of projects do require pre-approval. This is particularly the case with lighting projects or any custom projects. You just want to make sure that qualifying equipment's being installed, pre-approval is being met, and we can help again at PGE if you're needing help with the process and you want to learn how you move forward and get those incentives. So we're going to make the presentation available to you, and I thought this would be helpful to include kind of things you can do to take action or move forward. So just tracking energy consumption and setting goals, looking at you know, a month to month, how your energy usage looks, comparing it, you know, August of 2012 to August of 2011. Just making sure you're monitoring your energy use and keeping it under control, and you're doing things to impact your energy consumption. So review and implement low-cost suggestions. So we went through a lot of those today. So maybe review them and see, you know, well, what can I do when I'm done, and what can I implement right now. And ask PG about potential projects and incentives. Like I said, we're here to help you out. We can help you identify what might be best to look at first, best based on cost effectiveness and so on. Also recommend engaging employees and assign tasks. So maybe some of these things you kind of make a team effort and assign someone to review utility bills, and maybe someone else contacts PGE, and somebody else is responsible for looking at the low and no cost things. So I think it's helpful to kind of get everybody motivated and on board when you're trying to look at energy efficiency and kind of do the right thing there as an entire business. So as I mentioned before, we do offer free energy efficiency consultations. So typically, you know, we'll start by talking to you on the phone. If you need help on site, we're available to do that. Take a closer look at the equipment you have, learn more about the process of obtaining incentives. We're here to help. And you can visit us at portlandgeneral.com/business. That's our business customer area of the site. Basically, you kind of fill out an online form, and it's emailed to us, and we'll get back to you shortly. You're welcome to contact me directly. There's my phone number, and you can also send a request to our email box for our commercial customers requesting a consultation, so energy.consultation@pgn.com. So I encourage all of you to get in touch with us if you have questions about your building or any of the mechanical or lighting systems. So that wraps it up for me. I'm going to pass it back to Lorena for some questions.
Great, thank you, Garrett. And before we go into the questions, I did want to remind everybody we do have some upcoming webinars. The Intro to Energy Monitoring for Energy Savings would be a good one to find out how you can track energy consumption and set goals. I thought I'd also share, when Garrett said engage employees, a customer at a seminar shared that a really fun way that they did that was they bought fake money from like the dollar store, and they went around at night, you know, so the supervisor at the end of the day went around, and things that were not shut off, that were wasting money, he set this fake money on everything. And so the printer, if it was left on, or a monitor, he set that, and he made a competition, so the people that wasted the less money got a prize. And so I thought that was a neat way, an opportunity to get employees engaged, so I thought I'd share that. And we also, I think most of you have visited our Energy Education Center, but I wanted to remind you, you can take a look at our webinars and seminars on there, and then soon you'll also be able to download any recording of our webinars that you might have missed. So Garrett, and while we're answering the questions, I also, you'll see a polling come up to the right of the screen. Please give us your feedback on the webinar today and anything else that you'd like to see us offer or change. But Garrett, the first question is, can you just clarify what the T12 and T8 means?
Okay, so yeah, the T12 it's 1/8 of an inch. So a T12, 12/8 of an inch, it's 1.5 inches, and T8 is 8/8 of an inch, and it's 1 inch diameter. And the T12s operate off a older magnetic ballast, which is much less efficient. So they're a similar technology. It's just kind of the evolution of linear fluorescent.
Great, thanks. You talked about the thermostat and changing the temperature. If people are changing it back and forth with different temperatures throughout the day, does that make it less efficient? Does that use more power?
Potentially, it kind of depends on the system. I would say, like with a heat pump system, for example, it would probably have more of an impact than with a gas, natural gas and air conditioner. I guess it's pretty common. This happens a lot. It's kind of like the thermostat wars in an office or something. Everybody's can't agree on what they're most comfortable with. But I would say it would be, I guess, most impactful on a heat pump system compared to other systems. I guess if it is kind of a battle over the thermostat, finding maybe kind of a temperature that everybody's somewhat comfortable with, and some of the newer thermostats you can have them programmed so you need a password to get into it, or even as simple as just an old lockbox, which they've been around forever, and it just kind of limits access to it if that's an issue.
Okay. Garrett, the last question is, this says, I understand that RTUs can be retrofitted with more advanced controls such as multi-speed fans, demand control, ventilation, and save significant amounts. Do you have any experience with this?
Yeah, so actually, in fact, Energy Trust has a rooftop unit tune-up program that's available where this applies to newer HVAC rooftop units, and some of the things you were asking about are some of the things that are done to rooftop units. So it's basically demand ventilation where there's a sensor, and it's basically sensing occupancy, so it's pulling in less outside air when it's not needed based on occupancy. A lot of times the economizers on rooftop units, they were never set up properly, or they're out of calibration. Example would be is they're not pulling in enough outside air to get free cooling in the winter as they could. They're not opening up enough. They're not set to do that. So yeah, there can be some significant savings retrofitting or addressing kind of retro commissioning, I guess, of rooftop units.
Great, thank you, Garrett. And we did run out of time, and we have a couple more questions, but we'll type those up and we'll send you some additional links along with the recording of the session and the PDF of the material. So thank you again for joining us, and we'll stay online a little bit longer if any other questions come through, but please do take a couple minutes to fill out the polling survey for us. Thanks again.